All right, so I'd like you to go back to your notebooks under the 7.6 notes that we started yesterday. And what I want to do is add on a problem 5 and 6, because is that where we left off? Okay. So I want to do a problem 5 and I want to do a 6. I'm not going to tell you a method on these. I want to see if you can pick up on this. So I call this 7.6 continue. And you're going to want your formula sheet out in front of you as well. And you're going to want to make a quick check and make sure that your calculator is in degrees. So calculator in degrees. Again, you're back over to the notebook, and we're going to go right with number 5 here. And if I say solve, that's all I'm going to tell you. Solve, and you want to decipher some sort of method with this one. So we're going to go, how about cos x sine x? I want to go cos x sine x. And let's say that this is equal to negative sine of x. Okay, looking for a strategy here. Anyone have an idea? What do we want to do with this? Move the sine of x? Absolutely. Let's start with that. So we're going to go plus sine of x plus sine of x. And then over here, plus sine of x. All right, so I am left with the cosine of x multiplied by the sine of x plus the sine of x is equal to 0. All right, what do we notice about those terms? Hey, a factor, absolutely. So this one is going to be a GCF. GCF. These are both going to have sine of x. So sine of x is your GCF that comes in the front, leaving you with cos of x plus 1. These are the cases where it's okay to work with 2 trig functions because you were able to separate them. You guys see that? So you're able to isolate them and really work with them separately, which is why this works. Your problems yesterday, you wouldn't have been able to do that in GCF one of them. So now you're going to solve this taking your T-chart on either side here. And I have that the sine of x is equal to 0. I'm going to move this over at the same time just to cut that on the amount of writing. So cos of x is equal to negative 1. All right, so now I'm continuing here, and on the left-hand side, I want to sketch my unit circle. And on my unit circle, sine corresponds with the y value. Cosine corresponds with the x value. Yep. So again, unit circle. So you can sketch one of those if you'd like. And I'm looking for, where is my y value 0? 0 degrees and, yep, very good, 0 and 180. All right, over to the other side. Now I'm looking for, where is my x value equivalent to negative 1? This would be at 180. Do I have to list it twice? Of course not. So just 2 answers on this one. So this one, our final solutions are just 0 and 180 in degrees. All right, awesome. So let's throw in a number 6 here. And again, I'm going to leave off the strategy and see what you come up with. So I want to go number 6, and then we're going to backtrack to your worksheets. So I'm going to go 2 cosine of x multiplied by tan of x plus 3 times the tangent of x is equal to 0. Okay, so what's our strategy for 6? I heard it. GCF. Yep. What's our GCF here? Yep, very good, tangent. So I'm going to take out a tan of x. Again, that's the only time that you can work with these two trig functions at once because you're able to break it. So I get a 2 cosine of x and plus 3 equal to 0. So the left side, I'm going to be looking for where is tan of x equal to 0. So again, that is going to make reference to your unit circle. And on your unit circle, tangent is sine divided by cos. So sine divided by cos, meaning essentially y divided by x. So I want my y's to obviously be zeros. So here and here, same answers as before, 0 and 180 again. 0 and 180. And now I go over to the other side. So the other side, I have a 2 cos of x equal to -3 if I subtract that over. Divide by 2. Divide by 2. So I am left with the cosine of x is equal to -3 over 2. I did this on purpose too, because I don't know if we've seen this yet or not. So which quadrant is cosine negative? ASTC. Again, at this point, you are done working with that negative because you have correctly placed into those quadrants. So now in the calculator, what you would do is an inverse cosine function. So second cosine of 3 over 2. You're going to notice something. Error. Yep, absolutely. So this is not defined. So this side produces no legitimate answers. The reasoning behind that is when you do a cosine ratio, it is your adjacent over your hypotenuse. And isn't the hypotenuse always the biggest thing? Yeah, so that's never going to work. So whenever you try to do inverse trig function on sine or cos that is bigger than 1, you're going to get that answer that just gets rejected over there. So you don't have to do anything with that. So this question, answers are also 0 and 180. How do we feel on those two? Good. All right, now I want you to back to your worksheets and flip it over and let's go through 7, 8, and 9 here. So back to your sheets. So I'm on the back side of that worksheet. You did the first 6 for homework. All right, and let's look right at 7 to begin here. Again, your strategies are going to kind of differ depending on. All right, so in number 7, I'm wondering if anyone's eye is picking up on this already. So in number 7, I see the sine of 2x. Where is that located? Very good. That's a double angle identity. Double angle. So that is a formula sheet substitution. You're going to replace that with 2 sine x cos x. There's only one identity for that. Minus sine x cos x equal to cos of x, unless you want to shift that over already. It's up to you. Now, technically, on the left side of the equal sign, those are like terms. So 2 minus 1 would just give me sine x cos x. So sine x cos x. And I might as well shift that cosine of x over to the left as well. And then I'm hoping, again, I just wanted to give you more repetition with this so that you get comfortable. What method should I use here again? GCF, yep. So I'm going to take out a cosine of x to isolate that, leaving me with sine of x minus 1 equals 0. So then you're going to t-chart both sides separately. And it's looking like this is another unit circle. Yep, so I have cosine of x is equal to 0. Remember that cosine on your unit circle does pertain to that x. So where is x0? 90 and 270. Something different finally. Then you're going to go over to the other side here. So other side, I have sine of x is equal to 1, which is okay. You just cannot exceed 1. Sine of x is going to be your y coordinate on the unit circle. Where's the y equal to 1? 90. Let's say we already have it. All right, so these answers are just 90 and 270. How do we feel on 7? Pretty good? Okay. Number 8. I see a squared in this one. So this is a quadratic trig equation instead. Now I see secant squared x. So grab that formula sheet. When we do something squared, what category does that refer to? Yep, Pythagorean. So this you're going to swap in with your Pythagorean identity. And what do we replace secant squared x with? Very good. Tan squared x plus 1. Multiplied by the tan of x next to it, equal to the 4 tan of x on the other side. Very good. All right, distribute. I have 3 tan squared x plus 3 multiplied in a moment by tan of x. It's up to you guys. Do you want to move the 4 tan x over now? You might as well, because you know you're going to have to get this equal to 0 anyways. And again, these problems do get lengthy. So now I'm going to just distribute and work with these parentheses. So 3 tan squared x times tan x is 3 tan cubed x plus 3 tan x minus 4 tan x. Might be the first time you saw a cube come up. Pretty sure it is. So left side, I'm going to just leave that as 3 tan cubed x for the time being. And we have minus tan of x. And then that is equal to a 0. Okay. So what can I do next? Well, we can't do quadratic formula because it's not a quadratic. We have a yes. So you're going to take out a tan of x. You are left with 3 tan squared x minus 1 equals 0. Okay, the left side is going to be quick and easy. I think we already did tan of x of 0, didn't we? I think that was back in your notebook. So tan of x is equal to 0 is going to refer back to your unit circle. And on the unit circle, equivalent to sine over cos, meaning y over x needs to be 0, which was, what was it, 0, 180? Yeah, 0, 180 on your unit circle if you don't want to draw it again. All right, that takes care of that side. Now I have to do this trickier side. So we have 3 tan squared x equals 1. Divide by 3. I'm going to swing this over to the other side because we're going to run out of space here. Coming up here. So I have the tangent squared x equals 1/3. And what do we need to do to get rid of the squared? Square root. And what do you all forget to do every single time? Yes. One of the most common mistakes. You guys are notorious for making those really seemingly small mistakes. So I have the tangent of x is equal to plus and minus. Square root of 1 is 1. Square root of 3. I'm going to actually just leave it alone for a minute. So when you see this situation, which is what you saw come up on homework, this means that you are going to plot tangent every place that is positive, be it negative, which means how many answers are we going to get from this part? 4. You're going to have 4 answers. So I'm going to go where tan is positive first, so ASTC. And then go ahead and in your calculator, hit second tan, unless you know this, of 1 over radical 3. This is nice. This is exact value, actually, just fun rationalized. You guys remember it? It is 30. So first quadrant, my answer is 30 degrees. Third quadrant, my answer is 210. All right, so now this question is up to, I'm going to underline these, up to 4 answers. Now I'm going to place this where tangent is negative, which is the other 2 quadrants. So ASTC. Again, your point of reference is the same. So second tan is still going to give you that 30 degrees. And then I go 180 minus 30, which is 150. And 360 minus 30, which is 330. All right, so you're done. Answers are, oh, and you know what? I need to mention this. Because you're doing a review assignment on Delta Math, you guys listening? I don't know why, but it will mark your answer wrong if you do not type these in numeric order. So I'm going to write these in numeric order just to get you used to that. So the smallest one was 0. The next one was 30. 150, thank you. And then 180. And 210, thank you. And 330. I don't know why it can't handle that, but it can't. Okay. But I figure if I make you do it here, then you'll produce, you'll kind of have a good habit moving into those. How do I feel with number 8? Pretty good? Okay. Kind of like as long as they get. Number 9. Actually, I don't even need to do any identity work, do we? No. This is a quadratic again. So I'm going to get this equal to 0. So we're going to go a 4 sine squared x minus sine x minus 3 equals 0. Okay. Your choices are AC factoring or quadratic formula. I would always favor the AC factoring. However, I only gave you one quadratic formula yesterday. So do you want me to do this one quadratic formula? Does anybody? Are you guys comfortable if you had to use it? Okay. Again, happy to do it either way. So quadratic formula or AC, we favor the AC, I guess. Okay. So multiplies to negative 12 and adds to negative 1 would be negative 4 and positive 3. And then minus 4 sine of x, the AC method, plus 3 sine of x, and minus 3 equals 0. Remember that if this AC is making you uncomfortable with the trig function, you can still do quadratic formula, still full credit. So I'm going to take out a 4 sine of x, leaving me with sine of x minus 1, taking a 3 sine of x minus 1. Go from here. I have 4 sine of x plus 3 and sine of x minus 1. This one's easy. Sine of x equals 1. That's your unit circle. Y value 90 degrees. This one's your triangles. So 4 sine of x equals negative 3. So sine of x is negative 3/4. And this one's back to triangles. So ASTC, sine is negative below the x-axis. And then you got to go to the calculator again. So to get your reference angle, you're gonna go second sine 3/4. Does someone have this? 48.6, thank you. And then you're gonna do plus 180 minus 360. Answers would be 228.6. And quadrant 4 resulted in 311.4. Okay, so let's put them in order. 90 degrees, 228.6 degrees, and 311.4 degrees. How do you feel with the equations? Okay. Equations do make up a more significant part of your test in comparison to what we did before, so I wanted to give you extra practice on those. So here's what I want you to get started with your remaining time. You have a big review assignment that is due Friday morning at 9 a.m. I want you to pull out some paper and your formula sheets and get started on those. Tomorrow we'll go through your review sheet that I handed you yesterday. And then again, treat this homework assignment on Delta Math as like a 2-night assignment. So try to get like half of it done tonight, half of it tomorrow. It's not graded on accuracy again, so if you mistype something, it's okay. Don't panic. Questions on those? Okay, you've got a good 10 minutes. I want you to make valuable use of your time. And if you need to charge, there's a couple outlets on the left side of the room if you want to relocate over there. All right, so again, you've got that Delta Math assignment to start tonight, finish up tomorrow night, and test on Friday.